In this lesson, we are going to go back to using our TVM Solver application, financial app, to help us see how just playing around with some of the conditions of an investment or a loan can affect how much money you earn or have to pay back. Because playing with things like interest rates or the amount of time that you spend investing or letting an investment grow can really make a big effect. All right. So that's basically what the first paragraph says. Just that it's important to understand this. This is hopefully if you get this basic idea, even if you just come away with this basic idea that I'm going to present today, this might help you at some future time in your life when you're looking to make a big purchase or to save some money. All right. So let's just actually go through the examples and see what we get. Anna has $2,000 available, so she wants to invest it. It's 12% per year. It's compounded annually, so that's once a year. She wants the money in 10 years to finance her children's education. So those are the things that we know we need to put in. TVM Solver, remember that's just time value money. Here's my calculator, Easy Financial Calculators, TVM calculator. I downloaded it. All right, you may remember seeing this last lesson. So let's put the values in. So she has $2,000 available. Remember, put a minus sign in front of that 2,000. Ignore the payments one. Future value, that's what we're going to find. Annual rate was 12%. Periods. Well, if it was for 10 years, then it would be period. I guess it would be 10 periods, but we're going to do it year by year. So if you look at this table, I'm going to have to play with. That's what I'm going to have to change each time. So for 0 years, the number of periods will be 0. It's once per year, right? So go back to 12% here, or sorry, not the whole thing, per year. No, I'm still circling the wrong thing. I'll get there. Annually, that's the word I'm looking for. Annually means once a year. So, but we're going to do it year by year. So after 0 years, they'll have no periods have gone by. After 1 year, 1 period, 2 periods, 3 periods. Once a year for each of these number of years just means that's how many periods. So we're going to be changing that. But you can see we can do it quickly with a TVM Solver. So that part's going to change. We're going to keep playing with that. So for the first one, we're going to put 0 in, and then we'll play with that. I do need to change this from monthly to annually, once a year. And then future value, $2,000. It hasn't had time to grow. So I'm going to be going back and forth between these two things so that I can write them in. Hopefully it won't lag too much. Then after 1 year, I'll put a 1 in here. And I don't need to clear things. I don't need to reset it. I just change periods to 1, hit the FV button again, and now it says 2,240. So, I can leave the information in there, and it'll still work. I'll change periods to 2 for 2 years, FV 25808. I'm just going to round it to the nearest dollar, okay? So 25808, 2508, all right? And then 3 years, 2810, let's call it. Fortunately, OneNote's a little bit laggy, but 2810, and 4 years, and we get 3147. Okay, it's getting longer. So I know what the numbers are. You get the idea. So I would put it, I'm just going to fill in the rest of these values. So I'd put 5, 6, 7, 8, 9, 10 in for the different periods, and what I would get is 3525, 3948, 4421, 4951, 5546 6212. Now, remember, she hasn't done anything other than stick $2,000 in the bank and then just wait for stuff to happen. So this money growing every year is costing her nothing other than that she has to not use that $2,000. But of course, 12% per year, that's a very high interest rate. No bank is actually going to give you that interest rate. So this is exaggerated, but it is the idea of what's going on. Now, we want to graph this to see what the graph looks like. So let's do a nice green graph. Get some bigger dot. And let's plot these. So these are ordered pairs, right? So 0 and 2000 is an ordered pair. That'd be right there. Let's make this even bigger. Okay, 0 and 2000, that's right there. And then we have the next one, 1 and 2240. So 1, go up to, I have to estimate, but that's about halfway in between there. And then the next one was 2 and 2508. So that's about here. And so if I just keep plotting these ordered pairs, make sure that I'm, let's see, 7 was 4421, so that's actually about here. And then 4951 should be here. 5546 and 6,200. All right, I think that's about right. Looks approximately right. All right. I'm going to connect the dots with the smoothest curve that I can. Okay, not beautiful, but you get the idea. So it's definitely not a straight line. It is curving upwards. We've seen this kind of upward curve before. We call it exponential. So what we can see is that an investment, if it's got a compound interest, it's going to grow exponentially over time. And we've seen that before, but you can really see it quite distinctly using the financial calculator app that lets us just sort of see how things are snowballing. And it would continue like that. I mean, just this example's done, but, you know, we could see what's it like at 20 years. You know, well, let's see, at 10 years we had it at 6,211, right? So would it be double that at 20 years? Would it be 12,000? No, it's 19,000. It's almost 3 times as much. It's more than 3 times as much. Sorry, I take that back. What about 40 years? Would it be double that? 186,000. So that's crazy how fast things grow. Now, again, interest rate unrealistically high. No one's going to give you 12%, but the concept is very true. Let's take a look at the next example. So in this one, Tyler buys a house, $500,000. How much would he own in 5 years if the mortgage grows at a rate shown in the table below? I think that's a typo, though. I don't think we mean to say own. I think we mean to say owe. So let's fix that. Make that an E instead. How much would he owe in 5 years? So the biggest investment a lot of people make in their life is buying a house. Getting a good interest rate is hugely important. The difference of 1% interest rate can cost thousands of dollars, as we're going to see. So I don't want to give too much away, but this one's about seeing how just a different interest rate can make a big difference. So it's so when it says the amount of the investment, it's really the amount of the loan. Again, I'm just sort of being a bit picky here, but when you buy a house, a mortgage is really just a specialized loan. So when we talk about him buying a house for $500,000, we're assuming that Tyler doesn't own $500,000. He doesn't have a bank account with $500,000 sitting in it. So he's borrowing the money from the bank, and he'll have to pay it back bit by bit. How much is it going to be worth? All right. So what we have for this one is the principal is $500,000. 5 years is the time. All right. That's going to be our period. Quarterly, we have to look down here to see that it's compounded quarterly. That means that periods is going to be, as we've seen before, we have to multiply. That's our end value, so 5 times 4. So periods is going to be 20. And then we have the various interest rates. So what we're going to be playing with in this question is we're going to be playing with the interest rates. So in the last one, we changed the amount of periods. In this one, we're going to be changing the interest rate and keeping the periods the same. So let's reset. $500,000, make it negative $500,000. Skip payments, future value, that's what we're going to find. Annual rate, that's what we're going to change from one to the next. So the first one was 3%, so I'll just put 3 in for now because the first one in the table was 3%. Periods we saw was 20. That will stay the same. But the compounding was no longer annually, it was quarterly, so that matters. So the future value is $580,592. I'll ignore the cents again. So in other words, if he got a loan at a rate of 3% for a $500,000 mortgage, he would actually have to pay back $580,000 in 5 years. So it's a lot, but you know, that's sort of the way it goes. When you buy a house, it's an investment. You know, it grows in value too. So $580,592. So again, I'll do a couple of them, and then I'll just fill in the rest of the table. So the next one was what happens if we change the rate to 3.5%. This is bad in this case because this is you're borrowing money. You want a low rate when you're borrowing it. So as we increase the rate, the future value is going to go up, and we don't want that since we're paying this. $595,169. Basically, a 0.5% interest rate increase just jumped up the overall amount we have to pay by $15,000. Not nice. Let's change it to 4% and see what we get. $610.95. And again, you get the idea, so I probably don't need to do all of these. Let's do one more, though. Change it to 4.5%. Whoops, didn't mean to do that. 4.5% future value. $625,375. All right, so if we do 5%, it turns out to be $641 and $18, I believe, and then $657.33, and then $690, $210, and $70. Oops, I think I messed something up here. Did I skip something? $625. Oh yeah, I skipped one. Just this one here. So for 6%, it should be $673,427 or 28, I think, if I round it. And then $690, $210, and then $707, $3.89. Remember, these are dollars. These aren't just numbers. These take on a lot more personal meaning if this is actually your house you're buying. So again, everything's exaggerated here. But the difference between, in just 5 years, the amount of money you'd have to pay back at 3% and 7% is over $125,000. $125,000. Think about what you could buy with $125,000. The difference between 3% and 7%, that's what that is under these conditions. So interest rate makes a huge difference. Here's the last thing that makes a difference is compounding frequency. You may not think that makes a difference, and it won't make as big of a difference as interest rate, but it will make some difference. So in this one, Kyle has $1,000 to invest. That's our P. 10% per annum, 10 years, and then we're going to play with the compounding frequency. So that means we're going to change our periods. We're going to have to multiply 10 by different numbers to get our different periods. So this is an investment. So now we're back to some investing. They're not borrowing, they're investing. So $1,000, reset, negative 1,000. Annual rate was 10%. It was for 10 years. So I'm going to have to play with a couple things here. So first of all, we're going to go with annually. And so that means once a year. And like I said, it's for 10 years. So that means the period 1 times 10 is 10 periods. So the future value is $2,594. So let's change it to semi-annually. Okay, so I do need to change this to semi-annually, but I also have to change the periods. It's still 10 years, but now they're doing it twice a year. So twice a year means there's 20 periods altogether. And now it's $2,653. Okay, the next one is quarterly. Change this to quarterly. Now it's 10 years times 4 times a year, gives me periods, 40 periods. And the future value is 2685. Oops, 2685. Monthly, you get the idea. So now it's 12 times 10, so this becomes 120. Future value is 2707. Might as well do all of these ones because we can. There's only a couple left. So now we're up to weekly. Skip up to that one. 52 weeks in a year times 10 years is 520 periods. 2716. And finally, daily. That is a possibility. They could calculate the interest daily. There's 365 days in a year. So 365 days times 10 years is 3,650. And it's $2,718. So let's just take a look down this column. We started $2,500, $2,600. It jumped up by about $60 the first, going from annually to semi-annually. Now I'm just going to ballpark it here. So it jumped up by about $60 here. It jumped up by about $30 here. Jumped up by, what, 15, let's call it $22, I guess. Jumped up by about $9 and then increased by $2. So as we increase the compounding frequency, it definitely increases the value of our investment, or the cost of a loan if it was a loan. But the biggest gains are at the lower end, going from annual to semi-annual or semi-annual to quarterly. It's not quite as big a jump for the last one. Like going overall from annually to daily, for sure, then that's, what, $150? Maybe not that much. $120 anyway difference. between those two extremes. Makes a difference, but it definitely it varies. So if you're investing, the point is you want the compounding frequency to be as often as possible. So what conclusions can we draw? When you're changing any conditions in an investment or loan, the amount or the principal will also change. Doubling an interest rate more than doubles the total interest. Now that, as I said before, interest rate has got the biggest effect. So that is a huge one. So you really want to keep your eye on an interest rate. And that's because of compounding, of putting the interest back in. And also we saw the more frequent the compounding periods, the greater the effects of any change to the investment or loan. So that gives you a little extra boost.